Thank you. Thank you. Thank you. Yes, sir. Thank you, sir. Thank you. Thank you, sir. Uh, Good evening to one and all. Good afternoon to one and all. Sir, my screen is visible. Okay, sir. The STAAD Pro screen is visible, sir, right? Sir, is it visible? Okay, sir. One second, sir. Now is visible, sir? Okay, sir. Good afternoon to one and all. Very good afternoon for the wonderful session for next 5 days. Like a STAAD. I simply explain about STAAD Pro. What is mean by STAAD? What are the benefits in STAAD Pro? How to use the STAAD? Okay. First of all, the most of the Indian companies are using in STAAD Pro. It's a time saving one. For example, you already study MOS, structure of analysis, DRC subjects. The basic concept are using in STAAD Pro. You study MOS, mechanics of which you calculate the shear force and bending moment, and you study in structural analysis, moment distribution method, and DRC, you designing of beams and columns, reinforcement, etc. Then these are the main concept to design your concrete structures in STAAD Pro. How to save the time in STAAD? For example, you simply analyze a G plus 4 building. You calculate the manual G plus 4 building shear force and bending moment value. The time 1 day or 5 day will be taken. You analyze in STAAD, it just 5. You are beginner, you take a 1.5 hours or 3 hours will be design the G plus 4 building. You are a full finish, you will be go for 30 to 40 minutes, you will design the one G plus 4 building. That is time saving one. G plus 13 floors or 14 floors are there. You will be calculate the stack. It will be more time to be taken, the 4 days or 5 days. You will be analyzing the stack. They are mainly using in just 2 or 3 days. Sorry, just 2 or 3 hours will be G plus 14 plus analysis stack. Okay. The first of all, this is not a one-way section, something in interaction section also. Okay. First of all, what are the code books are using? The what are the code books are using in our field? Anyone? What are the code books our field are using? Okay. More. Yeah. Anyone? Go for interacting the one-way section. I will be take the whole class and etc. So I ask some right or wrong. Is tell me the main code books. What are the code books are using to analyze the whole structure in building? Anyone? Okay, I will tell one by one. Then this is an easy method to analyze the project in that book. First of all, you will confident in manual analysis. Some condition is there. Manual analysis, some condition, loads and others, etc. Okay. One framed section is there. What are the loads applying on your building? What are the loads? One is a live load, dead load, another one is a seismic and wind load, snow load, etc. How to find your live load for your building? Any reference for this live load? How to take the live load for your building? Anyone? You study in DRC. Anyone? Tell me, no problem. Right or wrong? Participants can unmute yourself and answer the question. 875 875 part 2. It's correct. It's for live load. Yeah. Another one dead load for IS 875 part 1. It's for dead load. IS 875 part 2 for live load and IS 875 part 3, part 4 and part 5 are there. The main part 5 for combination and vessel loads. There the code books are main code books for designing for your live load, dead load for your buildings. Okay. I tell about some main code books. So this PPT is visible. The PPT is visible, sir. PPT is not visible. So sir, is your connection connectivity is actually. One second, sir. I will share my Windows 3. So now it's visible, sir.
It's loading, sir. It's loading. It's visible now.
Okay. The first, the main code book is there refer the National Building Code. This is available in PDF in internet. The National Building Code is refer that all the buildings, all the code books from under the one code book is called National Building Code. You analyze the wind load or dead load, live load, certain conditions apply for this National Building Code. This is the main code book for designing in your building. The next code books already known, IS 456 2000. These are the main code books. Another one code book. Another code book is IS 875 Part 1. This is totally for dead loads, unit weight of the building and materials. IS 875 Part 1. The next one is the IS 875 Part 2. It's totally for live load, imposed load or live load. The next Part 3. The Part 3 for wind load, Part 5 for vessel loads and combination, Part 4 for snow loads. Okay, these are the five parts to the various loads. The next one, design aids for IS 456 for column designs, beam designs. You will refer this IS 456 1978. The which code book you will refer for detailing works? You will be detail the rebars like for example, assume as a 16 numbers of rebars in our column. How to provide the ties for this column? For example, 15 or 18 numbers of rebars in our one column. How to provide the ties? What code book you will be refer that for detailing works? Anyone? Which code book you will be refer the detailing works? For example, I have one column. The column rebar is a 16 numbers of rebar is there, one column. How to provide the my ties for this column? What code book you will be refer? These are our code books are IS 875 part is a live and dead load. The detailing code book are SP34. Okay, you will go refer the all the detailing words for column, beams, and others etc. This is the main code book for SP34. The 34 is a detailing code book. You refer in internet also, it's available. SP34 is a main code book. The next one is a this is a main code, another code book for causes and prevention of cracks. This code book IS 16700 is mainly using for tall stretches. You create the G plus 16 or 17 code books. 17 flows you will be refer the IS 16700 code books. The next one is the earthquake code book. This is the 1893 part 1 updated 2016. This is the earthquake code book. This is a ductility detailing for earthquake code books. Okay. I will tell about what is in this PPT. I will show this one photo. This is the one pick for this ISP34 code book page. This you will be designing your book or anything. You will be 6 rebars or 4 rebars. You will be easily provide the size for your column rebars. You will be more than 16 or 18 numbers, 12 number series. This is the maximum. This type of 200 into 1000 columns provide for G plus 17 apartment columns. See, this type of columns is provided for 6, 8, 10, 12, 16, 20, 24. 24 numbers of rebar is there. How to provide the ties? You refer the SP34 code books. You provide the reinforcement detail for your conditions. Okay, this is the main code book SP34. You'll be provide the 16 numbers of rebars, 12 numbers of rebars. You provide this type of ties and others, etc. This L-shaped column and the T-shaped column you will be provide the reinforcement details. Okay, and next one, There are simple conditions are there. Before you starting your STAAD Pro, some manual conditions is there. I tell about simple bit and then go for the hardware method is easy one. You simply created the STAAD modeling, that is the easy one. First step is a structural planning for RC building. The first condition is the position and orientation of columns. Okay. Anybody know already know the position and orientation of columns? They are the some points. The position and orientation. The first point is the compulsory provided the near the corner of the building. Near the corner of the building, it compulsory provides columns. The next point is the intersection of the beams and walls. You provide this column. Avoid the columns outside the wall. This is the main point. Depth of the column or contained with major axis. What is the depth of the column with contained with major axis? The moment of force is higher in column depth side. Okay. The moment of inertia force is depth side. For example, I will draw in paint. This is our column. For assume as this is our column. This is our breadth. Okay. This is our breadth. This is our depth. Column depth condition. My breadth is 200. My column assumption is a 600. Column depth. The inertia force high in this side. Okay. Depth side is moment of inertia is high. So you depth side will be apply the high length of the beam. That is a condition. This is the one column. This column is contained with the two beams. This is two beams. This is the one beam. This is the another one beam. Two beams are settled in one column. For example, this is the first beam. This is the second beam. Okay, this is the first beam, second beam. Um, this is the first beam. This is the second beam. This beam length is the 4 meter. This beam length is a 6 meter. For example, this beam is a 4 meter. This beam is the 6 meter. Which side will be apply for the beams column depth? The column depth orientation into longer beam side. Okay, this is the correct one. You apply for your orientation, which side you will be based on longer beam and load condition also. Your orientation on your column. For example, see this is our depth side. Depth side is fixed with longer beam. That is a condition. The inertia force is high in depth side. You will be provide the longer span of the beam in column depth side. That is the condition. Okay, now understand. For example, this is our column, this is our beam, this is on another beam. This is totally wrong. This is a long, for example, this is a longer, this is shorter beam, 4 meter. This is a longer beam, for example, 8 meter. But the column oriented into shorter beam side. So it's a failure. You will be change the orientation, the depth of the column orientation into longer beam side. That is the main condition for column positioning. Your first step is a plan creation, right? Not you directly go to analysis, not a first step. Understand? You go to analyze your STAAD Pro. That is a last step. Your first step is a plan creation. Your second step is a what is your second step? Column marking. That is the second step is the column marking. That is the second step. Your column marking. Then provide the orientation of the column also. That is the this condition. The inertia force is higher than let's say you will be apply the longer span of the beams. Okay. That is the main condition. The next condition is avoid the larger center to center distance of the column. You provide the larger to larger center distance, automatically the bending moment will be high, the deflection will be high. So avoid the larger center to center distance of the columns. That is the condition. Next one, column on property line. Okay, what is meant by column on property line? This is our boundary condition. For example, this is our boundary condition. This is our another boundary. Okay, this is our boundary, this is our another boundary. You will be provide the corner. This corner you will be provide the one column, but the column pedestal is not extend to other boundary. We'll choose what type of footing will be choose this area, this corner column. Go for what type of footing? You will be provided the SN normal isolated footing, but the pedal will be extended to another boundary, right? This is a boundary one. This is a boundary one, our area. This is a boundary to another area. This is a column will be provided for my corner of the boundary. But I provided the normal isolated foundation. My pedestal goes to another boundary. That is a wrong. What type of foundation will be used this area? Anyone? This area, this boundary conditions, maximum what type of foundation will be chosen? What type of footing? What type? Eccentric footing, okay. The maximum, the eccentric footing will be chosen for this type of boundary condition area. This is a main condition. You will be before you consider this all things after you will be design. That is an easy one. Okay. You go for boundary condition. This is our boundary. This is another boundary. This is a corner column. You provide the isolated footing. The automatically your pedestal will be extended to another boundary. That is a totally wrong. So this is a corner column I designed for eccentric footing. Okay, that is the main condition. Eccentric footing, the footing will be some design is there. So design this type of your column also not extended to other boundary. That is a condition for main steps. These are the main steps for column position near the corner of the building, intersection of the beam walls, avoid the position. This is a main point. This is a main point, and this is also main point. Okay, this is a position and orientation of the columns. These are the conditions as per IS 456 column conditions. This is the I have to tell you. Compare with the results. It's taken from IS 456 code books only. What is the minimum reinforcement and maximum? What are the minimum bars and others, etc. Okay. Next one. How to categorize your columns? Okay. The column is the main one. The beams are some conditions. The column is the main one. How to categorize your columns? The one is the internal column or axially loaded column. The side column axially loaded uniaxial bending. The corner column axial loaded and biaxial bending. You categorize into three types of columns. You will be studied in book. DRC are the internal columns, side columns, corner columns. These are the main conditions. Once you design your column, what are the conditions you will be taken? I design the column. What are the factors I will be considered for this column? One is the what what type of loads acting on this column and how much load acting on this column. This is the first one. You design your column means the first factor is the load on column. The second one is a moment on column. You design your column, you consider as a moment also. The moment will be comes in this column also. We consider the moment. The next step is the effective length of your column. The third step. The next step is the type of column, the short column or long column. Next one is a grouping column. The 5 to 10 columns in our building. More than 6 or 7 columns are same dimensions, same dimension. It's a grouping of columns. Understand? This more than 20 column is there. The 10 columns are same dimension. Sir? Sir? Sir?
Sorry, your voice is echoing a lot. So can you just fix it?
Okay, okay, sir. Okay, sir. So now it's clear, sir.
Yes, sir. It's better.
Oh, okay, sir. The next one is a grouping of
It's better, but it's still echoing.
Now it's clear, sir, or echo?
Yes, sir. That is better. Yeah.
Okay. The next one is these are the main conditions to design your columns. One is the loads on columns, then moment in columns, effective length and type of column and grouping of column and design a column section. These are the main conditions to design your column. Okay. These are the I share this PPT also. These are the conditions to take a effective length in your columns and short column or long column already studied in your book. The next one is you calculate the minimum eccentricity and allowable sentence, etc. This is the main consideration to consider the column design. The next one is the main important factor for reduction of imposed load. The main reduction as per IS 875 part 2 for reduction in imposed load on floors. This is a condition. You reduce this floors also. You consider the first floor, you not reduction is 0%. You go to second floor, reduction only for compressor number, so only for columns. You go for two floors, only 10% load will be reduced. And third floor, 20% will be reduced. Fourth floor, 30% will be reduced up to 5 to 10 floors, 40% over 10 floor, 50% will be reduced. This is a diagram for live load reduction factor for our floors. It's normally reduced only for compressor numbers column only. You reduce the live loads, not a beam or slab. The column only. This is the condition. The 30 kilonewton acting on this top. This is a top to bottom opposite condition. You comes under top to bottom, roof to bottom. The top of the roof acting on 30 kilonewton, no reduction. The next floor, 40 kilonewton, 30 plus 40. The totally 0.1 per 10 percentage is a 63 load. You reduce the column load, is a no problem. The code book will be provided. IS 875 part 2, you will be reduce the column load also. This is the next of all sixth floor. The total load 45 to 40 plus 50, 40, 45. This is 30, 40, 45 minus 40 percentage. Automatically convert into our load 153 kilonewton. Our total load is higher 180 or 200 something. But you reduce the live load factor, automatically your column load will be decreased. This is the main condition to decrease your column loads. So no problem. The IS 875 you will be study that IS 875. The IS 875 will be accepted for this live load reduction factor for columns. More than 15 floors will be reduced all the floors. These are the main conditions for column marking. Also beams or slabs are there after I tell you. Okay. Next one. Then go for STAAD Pro. First of all, I simply draw the one plan. Okay. For example, this is our plan. For example, this automatically this is our plan. I will be draw this plan. How to take the node point for our stat? This is I need a 1, 2, 3, 4, 5. This is a 2D. Today we'll discuss about 2D structure. I have G plus 4 floors. I create the G plus 4 floors. It is a 2D structure. This is the first column. This is the second one. This is the third one. This is the fourth one. Okay. This is the fourth one. But this dimension is a this is a 4 meter. This is a 4 meter. This is a 4 meter. Approximately I take 12 feet or 12 feet and 12 feet. What dimension you will be take to apply for the analyzing purpose? To take the 4 meter or which dimension you will be take the analyze for? This is a 2D structure. I take as 2D one. This is the first column. I need the 4 column for this G plus 4 for 2D. Okay. This is the first column, second one, third one. This is the fourth one. This is a 2D one. First one, second one, third one, fourth one. What distance will be taken? Anyone? For the node points, what distance will be taken? What distance? You take the 4 meter, next one is a 4 meter, 4 meter. This distance will be taken up. Which distance will be take to design for your building? 4 meter, 4 meter, 4 meter or anyone. Face to face distance or center to center distance. Anyone? You take the face to face distance or center to center distance. You take a analysis in your building. Okay. You take the center to center dimensions. Okay. This is your wall or column. You take the center. This is our center part. Right. This is our center. This is also our center. Okay. This is our center. You take any analysis software like a STAAD or E-tabs, anyone. You take the center to center distance. Okay. This is our center to center distance. You take the 4 meter, 4 meter, 4 meter. It's totally 12 meter. It's a totally wrong. You take the center to column, center to center distance is the correct one. For example, how to calculate the distance? For example, this is a 10 feet. This is a 12 feet. For example, 12 feet. This is a 9 inch. All walls are 9 inch. All columns are 9 inch by 9 inch or something. Okay. Then how to calculate this center to center distance? Anyone? What is the center to center distance? Anyone? The face to face distance is a 12 feet. Okay. Then how to calculate the center? This is the main concept for you designing in your project or anyone the company also. Then how to calculate the center to center distance? Anyone? The face to face is a 12 feet. Then center to center is a this face to face 12 feet. Okay. Then our half of the portion wall thickness 4.5 feet, 4.5 inch. This half totally 12 feet 9 inch for this center to center distance. And then same as this is our 12 feet face distance. To take the face distance and the center to center. This half and this half automatically 9 inch. Same like that. This is a 12 feet then center to center this half of the column, this half of the column 4.5, 4.5 totally 9 inch. This is the correct method to take the center to center distance for your columns, others, etc. Now understand how to take the center to center columns. Okay. You take the face to this is a face to face. You take the 4 meter 12 feet is totally wrong. Okay. This also. Then you take the center to center, that is a correct one. Now understand. You take the center to center means column center to center dimension. It's easily created in Revit software. Center to center dimensions. Okay. This is a 9 inch, 9 inch, 9 inch. Okay. The next one, the STAAD Pro. The STAAD Pro have three axes. Okay. STAAD Pro have three axes. One is the X, another is a Y, another one is a Z. It's a three axis. X, Y, Z. The STAAD Pro have three axes. I tell about three axes. What is meant by X, Y, and Z? The X is the length. Okay. X is the length. Y is a height. Okay. Y is a height. Z is a width. Okay. X is the length. Y is a height. Z is a width. These are the three main axes for your STAAD Pro. Same like a graph. This is our graph. This is our graph. Same like that. This is our graph. The center point is 0. The center point is 0. This direction will be plus. Direction also plus symbol. You go for backward, automatically minus. This side automatically minus. This is a simple method to create a node points in STAAD Pro basic on graph concept. This is the starting point. This is 0 point. Next is this point or plus. I need this side, simply go for minus symbol. This is our front side, automatically comes plus symbol. I go for back side, automatically provide the minus symbol. This is the axis. Starting point is a 0, then this side is a plus and opposite side is a minus, and this axis also plus and this axis also minus. Same thing is in STAAD Pro. Now understand. Three axes are there. X is the length, Y is the height, Z is the width. This direction is the X direction. So, okay. This is the X direction. This direction is the Y direction. Sorry, Z direction, width direction. This is the width direction. This is the X direction. Understand? This is the X direction. This is the width direction. And height is the Y direction. This is the main concept for axis in STAAD. Okay. The same diagram, how to apply the node points in STAAD Pro. Same 12 feet 9 inch, 12 feet 9 inch, 12 feet 9 inch. Simply go for new project. Go to space. I simply change into feet. Next, yes. Okay. Finish. So the three methods are in STAAD Pro. One is a snap node method. Another one is a structural wizard method. Another one is a geometry node method. There are three methods are there. I tell about one by one. The most of us buildings are unsymmetrical, right? In our field, the sum of the buildings are symmetrical. The most of the buildings are unsymmetrical. So you choose the geometry node method. Okay. The most of the buildings are unsymmetrical. How to apply the same node points in our STAAD Pro? Simply go to geometry, go to nodes. Okay, simply click this nodes. Automatically the nodes dialog box will be open. There are three axes already discussed about this three axes. X, Y, Z. The X is the length, Y is the height, and Z is the width of this axis. Okay, now understand. First point, the starting point of the building. Starting point is 0. Anywhere you go for, your starting point is 0, any building. So I simply enter that X is a 0 and Y height also 0. I tell about easy method how to apply the height. Then Z also 0. This is a 2D structure. So automatically this 2D structure means the Z will be 0. Okay. The next point, second point. Second point, center to center dimension. This is 12 feet. The 12 feet 9 inches. This is 12 feet. The 9 inch converted into feet. 9 inch 9 inch converted into feet. How to convert that? 9 divided by 12 automatically 0.75. 12.75 automatically, nothing but the inch is converted into feet. Automatically our 9 inch 9 divided by 12 automatically is converted into 0.75. I simply enter the 0.75. Y also 0, Z also 0. Our next point. The next point is a 12 feet 9 inch plus 12 feet 9 inch total distance. Add this 2 point. 12 feet 9 inch plus 12 feet 9 inch. Okay. 12 feet 24.75 1.5. Right. This is the calculation. Our feet is 9 inch. 9 divided by 12.75. That is the condition. Inch into feet. I simply go for 12.75 plus 12.75. Our second point. Automatically 25.5. Our second point is a second point 25.5. Our second point is a 25.5. I created this second point is 25.5. Next point, this cost last point. How to calculate the last point? 12.12 feet 9 inch plus 12 feet 9 inch plus 12 feet 9 inch. It's okay. 12 feet 9 inch. Totally added 12 feet 9 inch, 12 feet 9 inch, and 12 feet 9 inch. 12 feet converted into 7.5 into 3, 38.25. 12.75 plus 12.75 plus 12.75. Okay, 38.25. Your dimensions equal, you go for multiplication. Maximum the dimensions are unequal. So far, add your condition. That is the main concept. Add this condition. Totally, our center to center distance is 38.25. I simply go for node point 38.25. Simply enter this. Simply enter this my 4 points. Simply close it. See this, this is a node point. This is our 4 node points. First point, second point, third, fourth. Sometimes the node points are invisible. Sometimes the node points are invisible. How to visible this node points and node numbers? Node points and node numbers. Simply right click on your mouse. Go to labels. Okay. Go to labels. I need a node point and node numbers. Simply click and simply click apply. OK. This automatically my node point is visible and node numbers. This is my 4 columns. 4 footing node numbers. 1, 2, 3, 4. The 4 node numbers are visible. Understand? The other 4 node numbers are visible for this building. This is a condition. Simply go to right click labels. I need a node number and node point. Give OK. Automatically the node number will be created. The next step is I need a ground floor. How to create the ground floor? First I will be create this section, right? This is our longitudinal section. This is a cross section. Simply go to, I will create this. This is our distance, right? Okay, this is the ground floor 1, G plus 1, G plus 2 are rooftop. Okay, 1, 2, 3, 4. Ground floor, G plus 1, G plus 2 are terrace. Okay, these are the 4 numbers are there. 1, 4 slabs. 1, 2, 3, 4. This all distance are 12 feet 9 inch, 12 feet 9 inch, and 12 feet 9 inch. Okay. I will create this node point. This is the foundation. This is a footing foundation. I simply created this 12 feet 9 inches, 9 inches. Then how to create the building height? This is a ground level. Ground level to my bus floor beam level is a 5 feet. Okay. Ground level to our bus ground floor is a 5 feet. Other floors are 3 feet. Okay. Other threes are slabs are 3 feet high, but my for footing to ground floor slabs are 5 feet. How to create this section? The ground floor 5 feet and different heights. How to create the different heights for your building? This is a 5 feet. How to create the ground floor column and beam? Simply go to STAAD. First of all, these are different types of crushers. I tell about this is a node crusher. Only selecting for your node, simply select the node crusher. Next one is a beam crusher. This is a plate crusher using for slab. This is a surface crusher is using for shear walls, etc. Surface crusher. These are the 4 main crusher for using in your building. Okay, I selected this node points. I simply go to node crusher. Okay, I simply go to node crusher. I select this node. Then I need a ground floor for 5 feet. I need a ground floor for 5 feet. Simply go to geometry, go to translation repeat, not a circular repeat. You will be create a circular water tank and other. You will be go for circular repeat. You will be go for rectangular section and other. You will be go for translation repeat. Okay, I will go for geometry, translation, repeat. Simply go for translation, repeat. These are the three axes are there. It's also three axes. One is a x, another is a y, another one is a z. I raising my height of the building is a y direction, right? Y direction. I simply click this Y direction. My height of the ground floor is a 5 feet. I need the only one floor. This is step is a only one floor. I simply click this link step means this is a one node joining with other node. That is the link steps. I simply click this link steps. Okay. This automatically it will be created the ground floors. Then how to join this numbers? Simply go to geometry, add beam from point to point. Okay. In this point to this point, this point to this point, this point to this point. Now it's created the ground floor. Then how to create the another three slabs, another three slabs. Now it's created this floor. Then created this three slabs. How to create it? Same procedure. Simply select this slabs, sorry, beams, top of the beams. Then go to geometry, go to translation, repeat, go to y direction. But our height is a 3 feet. Our height is a 3 feet. Then go to number of steps. I need it 3 steps. Click this one, two, three. I need it link steps. Links, join with links. Click OK. Click this. Then go to geometry, translation, repeat, y direction, same 3 feet. I need it 3 steps, link steps. OK. Translation, repeat. Okay, it's created some problems in geometry node method. You simply go for another method also. Go to geometry, go to node method, same method, same typing method for this geometry method. Already it's created like a 5 meter, 5 meter. I will created the another node. Simply select this, then go to copy, then paste it. Paste it, then this column size. Simply go to total 8 meter. Sorry, simply click OK. Simply click this, automatically change the 8 meter, 5 plus 3 8, then 8 8 meter, 8 meter. Simply go to see this automatically. It simply created the 3 meters. This is another method. How to join the column and beam? Simply go to geometry, add beam from point to point. This automatically different sides have some problems. Go to this method. I simply join this columns and select this beam to this beam, and this beam. I need next to two slabs. Next to two slabs. Simply go to same procedure. Go to geometry nodes. Then copy this. Simply click this automatically. Go to copy. Click this. Paste. Okay. Then another one. I need another one. Simply go to paste. Then I change the size. This is a 5 meter. Then I go to this area. Total 8. 8 plus 3, 11. 11 meter, 11 feet height. This floor is also 11 feet. 11. 11. Change this height. This is another method. 11. This is also 11. This is also 11 plus 3, 14. 11 plus 3, 14. Simply minimize this is automatically it will be created. You go for that geometry node method, it will be difficult. Go for this copy and paste method. Simply go to geometry snap node, then join this column and click this, then click this and click this, then join this beams. Go to geometry node method, simply join your beams. Now it says simply created the same like this, it will be created. What is the height difference? This is a 5 feet height. These are all 3 feet height. That is a different. How to check the dimensions? Simply go to tools. Go to tools, dimension beams, display. This is a 5 feet, 3 feet. Automatically your dimension is a correct one. Now understand how to create the this type of increase your height of the building. Another method is the translation repeat. How to remove your dimensions? Same procedure. Simply go to dimension tools, dimension beams, remove your dimension. This is the first step for modeling in your building. Understand? This is a modeling. I will be created the X, Y, Z nodes, and also I created the G plus 3 floors. Okay. First, second, third. Ground floor, first floor, second floor, third. This is the modeling step is over. The next step or next 5 steps are there. That is the main step. One is a applying for a material. Next one is a size. Another one is a support. Next one is a load. And the next one is the analyze. These are the 5 steps to common for any buildings and steel also, steel structures also like roof structures, etc. There are the 5 steps. One is a material, another one is a property, another one is a support, another one is a load, another one is the load and analyze. These are the main steps. First of all, how to apply the materials? Go to modeling, go to general. This is the 5 steps. This is the main steps. One is the material, another one is a property, the specification for what you will be use the secondary beams. You release the moment also. That purpose I tell about later. How to release your secondary beams and others. Okay, that purpose you will be at the specification. Next one is a support. Next one is a load and definition and analyze. These are the main 5 steps to analyze in your building. Our first step, applying on material. Simply go to material. You click this, automatically your material dialog box will be open. You applying on steel material, stainless steel, aluminum, concrete. I need a concrete material. The inbuilt grade is there. How to add the new grade of concrete in your STAAD? Simply go to create option, then go to add the Poisson ratio and others, etc. You will be add the new grade of concrete. That is a method. I simply add the concrete. These are the 4 options. I select that concrete. One is the assign to selected beams, assign to view, assign to crusher, assign to edit list. This is the 2 numbers are mainly using. One is the assign to selected beams and assign to view. The assign to view is you are assign, click this assign to view, assign the one material, assigning for all the beams and column. The assign to selected beam means the which material you will be selected, that one particular material will be applying on your material. For example, see this. I select this column member. I apply for this one number only. Simply go to assign to selected beams. Assign yes. Sorry. Yeah, it's okay. Yes, yes. Automatically select this. Simply go to assign to view, assign. All the numbers will be assigned your concrete material. I need to select this. This one will be selected. Okay. This is the first step for material. I apply the concrete material for all the beams and columns. I simply select that, simply assign to view all the materials for concrete. Our second step is a property. This property is a based on your sizes. Okay. These are the this is the first one is a section database. Define material thickness. Section database is using for steel structures. Size section, channel section, that type you will be used. The define for concrete. The materials for slab, sorry, materials for material Young's modulus ratio, that one. The thickness for plate thickness and surface thickness, slab thickness and others, etc. I using concrete. I simply go to define. I simply go to define different size of sizes are there. Circular, rectangular, I need a T, trapezoidal, general sizes. Wrapped means used for pre-engineers building. That type of wrapped this side will be used. I simply am taking rectangular sections. Okay. I simply taking rectangular section. So now I created plan in feet. Now it's I change the unit feet into mm or meter. How to change the units inside this STAAD Pro? Simply go to tools, go to set correct input units, go to meter kilonewton. Okay. Then go to second step property. Then go to define. Okay. Then rectangular. I simply select the same sizes for all the columns. Go to width is our width is 0.23, our depth is 0.3. Okay, based on trial condition, trial and error only. Based on trial condition, I provided the column size is 0.23, our depth size is sir. Yes sir.
The screen is not properly. Can you just reshare it and again present it?
Okay sir. So now it's visible sir.
It's loading.
It's visible sir.
No, sir. Not yet, sir.
Now it's visible, sir. Now it's visible, sir.
It's loading. So it's loading. It's loading, sir.
It's visible, sir.
Not
The STAAD Pro screen is visible, sir. Oh, okay, sir. Okay, sir. These are the second step to how to apply the properties. Then go to properties, then go to define. It's for concrete. Simply the second is define. Then go to rectangular. Then go to sizes. I fix the column size for 0.23 into 0.3. Only trial and error method. Okay, then click add. Then close. The next one is a beam size. The beam have some thumb rules are there. 1 feet equal to 1 inch. That is our beam size have 12 inch. So 12 feet. 12 feet have 12 inch. 12 inch means 1 feet thumb rule. So I simply go to define, go to rectangular, simply click this 0.23 into zero point 0.3. I apply the beam and column size are same sizes. I apply the beam and columns are same size. How to differentiate the beam and column sizes? First of all, how to select my columns? Okay, simply go to select option beam parallel to column in y-axis. Right. Simply go to beam parallel to y-axis. Select this column. Then go to assign to selected beams. You will put the assign to view. You select all the beams and columns. Simply go to assign to selected beams. Assign yes. The automatically number will be created. Next beam. How to select the beam numbers? Simply go to select option beam parallel to z direction. Sorry, x direction. Beam parallel to x direction. This is x direction, not a z direction is a 0. So select beam parallel to z direction. Then assign to selected beams. Assign yes. Automatically our material second step our material will be applied. First step is the material will be applied. The second step is the property will be applied for our beam and a column. Our second step will be completed. Our third step is the support. The properties I apply the column and beam. The third step is a support. How to apply the supports? This is support dialog box. Simply go to create. These are the so many supports are there. Pinned, fixed, but enforced, roller, different types of that. I simply go to fixed end supports. I simply go to fixed end support. Simply add this support. Then how to apply the supports for this end supports? Simply select that support, then select this corner. And then how to set the another node points? Control, select this 4 node points. Then go to assign to selected node points. Assign yes. So automatically your support will be created. Our first step is a material. Second step is a property column and beam. The third step is a support. It will be created. The next step is a load. These are the load and definition are main steps. How to give the UDL loads and concentration loads for different conditions. Okay. How to give the UDL loads and different conditions for different conditions. Okay. First of all, how to add the dead load and live load. Simply go to load case detail. Add. First of all, I go to add my sulfate for the building. Simply click this dead load, add the next one, load case detail. Go to add, next one is a live load. Simply click add. First of all, I create the load case, one is a dead load, then another one is a live load. Then how to add the dead load? Simply click load case 1, add, then go to sulfate. Automatically the STAAD Pro will be calculate the sulfate also. Simply click this sulfate, add, close. Click this sulfate, assign to view. All the sulfate will be calculated. Assign to view, assign, yes. This automatically it will be applied. Then the member loads are you studied in MOS, etc. There is a one of the load, the point load and UDL load, etc. The UDL load is nothing but it's a brick load. The brick load is taken from IS 875 part 2. The concentration loads in the beam is column load. That is a condition. Some of the columns will be acting on the beam. That is called point load. Some of the secondary beams acting on the main beam. That is also considered as a point load. You didn't study in mechanics of solids and etc. That is a UDL load is a brick load. Then point load is a column floating column load or secondary beam load. That is a point load. Okay. Then how to apply the UDL load and concentration load. Load. First of all, I fix this dimension. Simply go to tools, dimensions, display. Okay. These are all 3.89 meters. Okay. These are all 3.89 meters means 12 feet 9 inches. Then how to apply the loads? This is our load. Okay. Then simply go to load case 2. I apply the UDL load. Load case 2, add. Go to member load. This is different types of load. Uniform force is a UDL load. It is a moment. You apply some moment for your building. Then concentration load is a point load. This is a concentration moment also. Linear varying and trapezoidal loads and hydrostatic. The hydrostatic load is acting on your water tank and others, etc. Then pre-air posters, fixed ends. These are the some load cases. We'll discuss about uniform force and concentration force. Okay. First one, uniform force. How to apply the load? I calculated the some brick load. Gamma into density into wall thickness into height into per meter. For example, 10 kilonewton per meter. Give the minus, it's all our gravity. So you put the minus value. Minus 10 feet, it's a gravity. Automatically put the 10 feet is a minus 1. Simply click add. This minus 10 is I need a full of I need this value minus 10. Simply click this beam, assign to selected beam, assign yes. Then how to reduce this load size? Simply go to top bar, select this load option. Automatically it will be reduced. For example, I reduce some load size 8. It's good. Next load. This is a total acting on this. Next, I started my UDL load in 1 meter after this beam. Okay, I started the UDL load is 1 meter after this beam. How to started this or 0.89 meter. I started from 0.89 meter to this total load. How to act on this load? Simply go to load cast 2, add, then go to member load concentration force. This is 10 meter. This is our starting distance. Starting distance is a 0.89 meter. D2 is a total distance 3.8 meter. The second beams I need a starting from after 0.89 meter. So D1 is a 0.89 meter, D2 is a total end of the distance 3.89 meter. Simply click add close. Simply click this, select this beam, assign to select, assign yes. Sorry, I do not put sorry minus. Simply go to how to edit this. Simply select this, edit, then go to select change. This automatically this is started from 0.89 meter. Now understand how to give the distance from this another to starting or mid of the portion to any. How to give the mid of the portions? How to apply? This is the 3.89. Starting point is 89, ending with 1.5. How to apply? Simply go to load case detail, same condition. Add, go to member load. This is my member load minus 8. The starting distance is 0.89. Our ending distance is 1.5. Simply click add. Select this load and select this beam. Go to assign to selected beams. Assign yes. This automatically our starting distance from ending distance. This is the condition to applying the different varying of the load conditions in our building. Simply go to load case and member load. So D1 is a starting distance, D2 is a ending distance. You apply for the starting distance this meter, ending this meter. Same like that. I need this starting from 1 meter, ending with this end. Simply go to load case, add member load is a minus 10 feet. Then go to starting from 1 meter, ending with my corner 3.89. Simply click add, select that beam, select that load, beam, assign to selected beam, assign yes. This automatically started from 1 meter, then as ended with 3.89. That is the condition for you adding the different types of UDL spacing in your building. Understand how to add the different spacing in your building. Next one is a concentration load, point load. Simply go to load case to add, then go to member load concentration force. So that is called point load. The secondary beams acting on your main beam is considered as a point load. Simply click this concentration floor. My concentration floor is 10 feet from the distance of 0.89 meter. 0.89. Simply click this add close. Click this or simply click this assign to select distance, assign yes. Automatically our point load is acting on this 0.89 meter. I need this point load on this joint. I need this joint. This point load 15 kilonewton acting on this joint. How to apply this joint? Simply go to load case details, add, go to member load concentration force. That point is acting on minus 15. Then go to 3.89, add, then go to select, then go to assign to selected beam, assign, then go to load options. Is automatically add on this point. This is the condition to adding the different types of concentration load and other loads, etc. Then how to add the midpoint? 3.89 divided by 12. 3.89 divided by 2. 1.945. I acting on the concentration mid 1.945. Simply go to load case detail, add, go to member load concentration force minus 1.894. Sorry, load is a 10. This is a 1.894. Add, select this load, then assign to selected beams, assign yes. Automatically add on the center portion. This would have added in point load and others. Now understand how to add the UDS loads for your beam and different conditions for your point load. That is the main load condition for your building. How to apply the different point loads for your different spacing and different UDL loads for your different spacing. How to see the load values for your UDL load and point loads? Simply right click on your mouse, go to labels. Okay, go to labels, load values. Okay, load values, apply, okay. This automatically our load values are visible. This UDL is a 10 kilonewton, this is a 8 kilonewton, this is also 10, this is also 8, 10 minus, applying on the different condition of the loads. Okay. The second step of the load condition is over. The next step is a combination for your load into factor of safety. Combination for your load. How to fix the combination for your load? Simply go to load case details, go to add. Simply go to load case details, add, go to define combinations. Okay, this is a normal one, define combination. Two loads are there. Convert into this side. Simply click this double arrow. Automatically load case 1 and a load case 2. Our factor of safety is 1.5. Then this is also 1.5. Simply click this 1.5. This is automatically, this is a 10. This is also 10. This is also 15. I added into 1.5. Add, close. Simply click this is automatically, this is a 15, this is 23, this is a 15. Automatically you add the 1.5, the automatically is converted to factor of safety. That is a time saving one. You simply add the all the point load and other load. Simply go to combinations, then go to define combinations. You simply add 1.5, automatically you will be add the combinations. Okay, this next four steps are over. The material step is over. The property, support, load and conditions, different load acting on your condition, that is over. The next fifth step is the analyzing one. The next step is the analyzing one. How to analyze your structure? Simply go to analyze and print. Click this analyze and print. Go to no print, add, close, then go to analyze, run analyze, save. It is automatically save this project. It's come no error. This is a main one. You will be error in your project. You will be redesign in your full project also. The zero warning will becomes you redesign this your project. The notes will be not considered. You consider one. This is zero warning and zero error. Is a no problem. You will be any error, two or three errors or warnings is there. You will be considered and redesign in your structures. Okay. This is the main concept for errors and warning. You will be redesign your structures also. Now understand the error and warning will be considered. Once you any you will be not given the materials or property any sizes, its error will be comes. Also warnings will be comes to identify this structures also. Now understand. Now the five steps are over. We will be modeling. Go to general. I apply the materials, properties, supports, and load and definition. The five steps are over in modeling. The next step is a post processing. How to see the shear force, bending moment, reactions, deflection, and stresses, etc. in STAAD Pro. Okay. Simply go to post processing. Simply go to post processing, then go to I take the combination only, the combination only in maximum value. This load case one hour dead load and live load is a minimum and minimum. You go to combination load, it will be maximum load. Simply click this combination load, then click ok. Simply click this combination load, then click ok. Then next one, how to see the bending moment, shear force, deflection and other values. This is the options. The first one is the deflection value. You calculate the deflection for your beams. And this is one is the beam stress. This is the main one, bending moment, y direction, z direction. This is shear force, is the direction, y direction, axial force and etc. This is a torsion force. Okay. Today we'll This is on how to see the values. Okay, tomorrow we'll briefly discuss on how to see the bending moment values. Simply go to click this bending moment. See this, the bending moment is differs on load condition. This is a combination load. There no bending moment is there, so is no load is there. It is only for loads is there, so certain loads, so bending moment will be up here. How to see the bending moment values? Simply go to result, view value, beam result, bending. I need a end span, mid. Go click this, annotate this, or otherwise simply go to view value, beam result. I first one I need is mid values. Simply click this, automatically this is the dimension is there. Is there, simply go to dimensions, remove the dimensions. Now it's visible, right? This is bending moment value. This is the higher bending moment value in 11. This a load will be given. This is a no bending moment. This is a 2. It's also same. No load is there. Simply go to result, view value, beam result. This is a end. Simply go to anode. This automatically. You will be scroll this automatically. See the bending moment values. This is a point load acting on this is bending moment values and others, etc. Next one, shear force. Simply go to shear force in y direction. This is shear force high in this direction acting on the load. How to see the values for this shear force? Simply go to simply go to result, view value, beam result, untick this all. Then go to shear. In the shear value is I tomorrow I talk about what is the bending moment, how to calculate the bending moments and shear force and others, etc. Okay. Today we'll discuss about how to see the values. The bending moment higher in end condition also. I click this end condition, annotate this automatically. Simply zoom this, automatically see the shear force diagram. This is also deflection diagram. Then reactions. Then simply go to click this reaction. These loads are taken into footing loads. This column is a total 67 loads. This is a 126, this is a 125, this is a 33. These are the loads are transferred to columns. Understand? These are the loads transferred to column for this conditions. Now understand how to analyze this structure, how to see the shear force, bending moment, axial reactions, others, etc. Tomorrow we'll discuss about how to apply the beams in shears in real structures and bending, others, etc. Then how to design the same like a beam column, how to take the reinforcement with check with the IS code books. Okay, tomorrow will be briefly discuss on bending moment, shears and others, etc. Okay, tomorrow will I conclude this section now itself. Tomorrow we'll discuss on shear force and bending moment briefly, and designing of columns, beams, and other etc. 3D structures also. Okay.
Before having a webinar, we will check that box from how to design of column in STAAD Pro software.
Sir, I tell about 3D structure in briefly. I creating a 3D structure. I tell about how to orientation of the column also. Tomorrow in Thank you, sir.
So same here.